Hello everybody, this is Dr. Imran Aziz, and today we'll talk what is distortion, what is distortionless transmission, and what is linear phase response. So what is distortion? The distortion is that when a signal changes its form or shape during the transmission, we say that the signal is distorted, as you can see over here. And this distortion, it mainly occurs in composite signals, as we know that a practical signal is normally composed of a lot of other signals. Like we see the signal over here, this is composed of different sinusoids, which we see on the right side. So this is one sinusoid with the comparatively lower frequency and higher amplitude, then another sinusoid with comparatively lower amplitude and higher frequency, and then a further higher frequency over here. So all these sinusoids, they make up this composite signal. So distortion, it mainly occurs in the composite signals because each frequency component in the composite signal has its own propagation speed when traveling through the medium. And when different components have different speeds, it means that they arrive with different delays at the receiver. This is the main reason for distortion, and thus the signal components have different phases at the receiver than they had at the source, which we can see over here. So if this is the transmitted signal at the receiver, because of different traveling speeds of different frequency components, we have different phases at the receiver, because of which the shape of the signal has been changed when reached at the receiver. So where does the distortion come from? The main reason for distortion is frequency selective attenuation. Different components, different frequency components have different attenuation, and also different frequency components have different phase change. This is the main reason for distortion. And also multi-path effects. Signal reaches the destination from different paths with different delays, and also Doppler shift, where the signal changes its frequency. So these are the main reasons for distortion. And how can we correct the distortion? As we know that distortion can severely degrade the quality of communication system. The equalizing circuits at the receiver, they can help to correct the distortion. How can they do that? We can use the equalizers which have gain and phase characteristics which are complementary to those of the channel. What does it mean? It means that if we know that the signal, when it reaches the receiver, it will have a shape like this. So we can design a complementary circuit with complementary gain and phase characteristics, so that when this signal reaches the receiver, it gets corrected automatically. So if channel distortion is known, it can be pre-compensated at the transmitter, and then receiver will get the corrected signal. So this is how we can correct the distortion. And this equalization and pre-compensation are particularly important in wireless communications compared to landline systems. Now, what is the distortion-less transmission? As we saw that the main reason for distortion is frequency selective attenuation and phase change. So if all the frequency components in a signal undergo same amplitude distortion, then there will be no distortion. And you can see over here, so this is the frequency and this is the amplitude response. If this is constant, which means each frequency component will have same distortion, will have same attenuation. So this is one of the conditions for distortionless transmission. And what is the second condition? Second condition says that the phase shift is linear with respect to frequency. You can see over here that this is the phase curve, which is linear with respect to frequency. What it means is that the higher frequency components, we can see over here. So in the composite signal, the individual signals which have lower frequency, they must undergo lower phase change, while the frequency components which have higher frequency, they must undergo higher phase change. So you can see over here, for example, the signal reaches the receiver at this point. So this component has a phase of 180 degrees. This component has a phase of 360 degrees. while this component has a phase of 720 degrees. So this is exactly what it means, that for higher frequency components, the signal components must undergo higher phase shift or higher phase change. So this is the other condition for the distortionless transmission. So then this is what it says, that each frequency component undergoes the same time delay, because when the phase change is different with respect to frequency, then the time delay will be same for each frequency component. Thank you very much.